this is my submission for Lab 2001, and I am doing Bogosort. So the premise of Bogosort is just take any array of any size n. I'm actually going to decrease my size n because that is a lot, and randomize it. And if it's sorted after you've randomized it, congratulations, you're done. And if it's not, randomize it again, and just keep doing that until your array is sorted. And so I've got some helper methods down here. I'm going to zoom out a little bit just so you can see. Um, swap is one of the key functions to Bogosort, and this just takes any array R and swaps elements A and B. And in the actual Bogosort method, I am checking whether or not the array is sorted using this while loop. And times is actually just a static variable I've declared in the class so that I can count how many times Bogosort has run, just for some information. Same here, this is like a timer and stuff just to see how long it takes for Bogosort to sort any array. And then if it's not sorted, you're just going to shuffle the array. And shuffle goes through every element in the array and swaps it with any random other element in the array um, in a given index. So if I run this code, I'm going to change the lower and upper bound values for what values my array can have, which is what I'm doing right here. It's just assigning random values to an array of size n. It's going to have, I'm going to have Bogosort sort an array of size 10, and this print line is going to tell us how many milliseconds it takes to print, how many how many times Bogosort was actually called, and how many elements it did sort. So as we can see here, this is the starting array, unsorted, and Bogosort took 103 milliseconds and 875,000 attempts to sort just 10 elements. And if we go down here, we can see that it was in fact sorted properly. And so I can just keep running this over and over and over, and the time is going to vary pretty significantly just because this is an entirely random sorting algorithm, and so um, sometimes it'll get it after the 1000th try. Other times it'll take 875,000 like it did that time. 152, 447, 14 milliseconds. It's really a gamble, but ultimately, um, as you increase the number of elements in the array that you're sorting with Bogosort, it takes more and more and more and more time to actually do the sort. So I'm actually going to end this so it doesn't eat up my resources. But if I go to Desmos, and we're going to graph it, we're just going to say ov n equals, and this will be for, for Bogosort. I don't remember it off the top of my head, so we're going to Google it. Average performance of n plus 1 factorial. So we'll just do n plus 1 factorial. Oh, whoops. Gotta fix that. Where n is greater than 0. So as you can see, as the number of elements increases, it takes more and more time. So I've got 20 elements in my array right now. So if we put in O of 20, yeah, it's not good. So comparing this to say like x log x for n log n, or just log of n, or just n, or 1, oh sorry, y equals 1. We can see that by far Bogosort is one of the most efficient. So I'm going to go through this now with a debugger. We're gonna put a breakpoint here and debug. Alright, so starting off, this is n, obviously 20. That's how many elements we have in our array, A-R-R-A-Y, right here. And this is just system nano time. We're not going to worry about it. It's just for the timer. So if we step into, where is it? There we go. we're gonna step into Bogosort. Gonna go down here. So we're checking whether or not it's sorted. Can I expand these? No, okay. And keep stepping in. So as we can see, now it jumps up to is sorted right here where this blue arrow is. And it's going to check iteratively for each element in the array whether or not they're in the correct order. And if it's not, we've returned false. So we're going to jump back down to this while loop. And since it's false, this is going to actually execute the code inside the while loop. Times plus plus, and times is up here, so now it's 1. And then it's going to shuffle the array, and now we'll jump into shuffle. And shuffle, as you can see here, we're going to call swap, and now we're going to jump back to swap, do the swap, and here A and B are both 0, apparently. That's fine. They'll probably change eventually. So if we just keep running this, you can see just how many times we're gonna have to run these, because this is still just the very first time that Bogosort has actually run. So I'm going to step out and just step across. So now we're just going to check it again. It's not sorted, increase times, and shuffle the array. And just do this over and over and over and over and over. And you can probably see just how many times this is going to take for larger and larger lists, because realistically, you're not going to be sorting anything with 20 elements in it. You're going to be sorting stuff with hundreds of thousands, and it's not good. Bogosort is not good at all. You don't want to use it whenever possible. However, some people do. It's kind of a joke. Wikipedia calls it a joke, I'm pretty sure, and they're absolutely correct. So I'm just going to see how many elements I can actually reasonably sort. This is probably going to take a decent amount of time, but Java is not using that much memory, so we could probably change that in the compiler settings somewhere, but I'm not going to do that right now. But yeah, it's not efficient at all. Let's go with like 11, because 10 ran all right earlier. See, so if we have 10 elements, I'm just going to use this as a base case. I'm not going to run multiple. 10 elements, and it takes 12. Okay, that was a lucky one. It takes 300 milliseconds for just 10 elements. If we scroll back up, 11 elements took 1.5 seconds, which is way, way slower, and that's just a 1 element difference. So I'm pretty sure you can picture what it would be like for thousands of elements to be sorted using Bogosort and how inefficient it would really be.